My name is Stephen Carter. I'm a Principal Solutions Architect with Ansible, and I also have with me here the esteemed Peter Sprygada, Distinguished Engineer, also with Ansible. We're here to talk to you about hybrid cloud network interconnect with Ansible. A little bit about the journey we'll be taking you on today, and give you a little bit of background as to why we're asking you for 45 minutes of your life to listen to us. Then we'll talk about siloed automation, or at least how it exists today in cloud, and then our approach with model-driven automation and how it cures what ails you. And then we'll do a demo to tell you a little bit or show you a little bit about what we do with models, and then we'll wrap up with questions. A little bit of housekeeping. We've built in time for questions. You can either ask the questions throughout or you can queue them up till the end. Another bit of housekeeping. I don't always inject humor into my presentations, but when I do, I send it via UDP. The problem being that I never know whether you got it or not. Oh, that's my litmus test to figure out how many networking people are in the audience. Clearly not very many. But why are we here today? We're here to talk about silos. Silos are basically a byproduct of choice. And there is so much choice in IT today. You have choice of operating systems. You have choice of automation tools. You have choice of where you put your computing. Even computing is very complex. You can put it on-prem physical, on-prem traditional virtual, on-prem cloud, off-prem traditional virtual, and the list goes on and on and on. Generally, choice is a good thing. The problem is too much choice could be bad because every time you make a choice to add another part to your IT infrastructure, you add complexity. And too much complexity could increase the cost and could decrease your resiliency to the point to where it fights against the very reason that you've added this cloud capacity, for example, to your infrastructure in the first place. In general, we believe that automation is a solution to that, and in particular, model-driven automation. And that's what we're going to talk about with you today. And we are going to start in the beginning, or at least that part of the beginning that suits my narrative. Not the very beginning of computing, but where computing became common enough to where computers started coagulating in different places around the planet, generally universities and laboratories. And in these places of coagulation, each of these institutions connected these computers together so that the computers could work as a part of a whole and not on their own. The problem is that when you wanted to collaborate with one of these institutions or you wanted to access one of these silos, one of these islands of compute, you had limited choices. You could use a modem and dial in to this computer, right? Or you could take, for example, a long wire and connect an institution to another institution at some sort of port and presence or meet-me place. But it was difficult. And part of the difficulties were each of these places had their parochial peculiarities. They had different media, for example. They had different protocols. And it caused problems. But then the networkers came and said, let there be routers. And these routers connected all of these different islands of compute. And where they needed to, they would translate between protocols and translate between media and allowed these disparate islands of compute to become one connected internet. And this connected internet brought people together and eventually was delivered to your door. And the networker saw this and said it was good. And then we get to today. We have cloud, right? And cloud is becoming ubiquitous enough to where it is coagulating in different places. And each of these places have their parochial peculiarities of how they set up networks and how you connect to them and how you input policy and whatnot. And if you want to connect to these clouds, you can use a VPN and sort of dial in the 2010 equivalent of dialing in to connect to these clouds. Or if you wanted to connect these clouds to one another or connect these clouds to your on-prem site, you could string white wires, virtual though they may be, and go to meet-me places. And each of the clouds have these mechanisms for doing this. We've got virtual private gateways and VPN gateways and cloud VPN. And then if you want to use the virtual wire connection method, you've got direct connect, express route, dedicated internet. Different ways of doing the same thing. And then even within the cloud, different ways of deploying networks. Again, every single time you deploy a network, you have to deal with the complexity of how that network or how that cloud does these things. And as you can see here, they can't even agree on the icons to use. It's incredibly confusing, frankly. To make it easier, each of these cloud providers provide automation, a way to automate those things, those cloud things. And there are ways to automate the network things on-prem. And there are ways to automate the compute things on-prem. Each of them have their own ways of automating the things, right? But the problem is that automated silos are still silos, and adding new silos still adds complexity to your overall IT operation. But what if we could give you the proverbial easy button, right? What if every time you wanted to add cloud capacity or add a new cloud provider, you didn't have to worry about those parochial peculiarities and how to translate your architecture and your policy into their ecosystem, into their infrastructure? What if you just had to say, give me some of that yummy cloud, and we could give you what you wanted? What if we could define the architecture once and deploy it many, many times over multiple cloud providers? Am I building up enough anticipation here? So the networkers to the rescue again with models. About a decade or so, a lot of the networking companies realized that they have lots of things. They have lots of routers, lots of types of routers, lots of switches, lots of devices. And each of these devices had different operating systems, and you could configure them in different ways. Even a single vendor would have multiple hardware platforms and multiple software platforms, confusing them mightily. And so what they did was they worked to model these things into more simple things of routers, for example. So it didn't matter the vendor router or the hardware or the vendor of the router or the hardware of the router or the operating system of the router. They modeled a router as a router because all routers have some commonality, and it's really that commonality that matters when you're trying to route the packets around. They, in particular, developed a modeling language called Yang, yet another generation, to describe these models, to describe the config and the state of these networks. Well, what if we took this idea? What if we took this idea of abstracting network things into simple things with models, and not worrying about the parochial, and not having to worry about the parochial peculiarities, and we applied it to the silos of cloud automation. And if you look here, I've got two different automation templates, two different automation mechanisms from two different cloud providers, two different infrastructure as code approaches. Infrastructure as code approaches. That sounded very weird. I apologize. What you have here is lots and lots of words, so many words, but only a few things matter in this. These are setting up a single network on that cloud. And as you can see here, there are only two things that really matter, right? There is the CIDR, that is the network address of that network, and there's the name of it. And there are some differences in how that name is represented, but that's relatively easily handled. But you certainly don't need all the words around it, right? This is the idea of distilling these templates, these templates that are opinionated to their particular infrastructure, distilling them down to the nougaty goodness of the important bits that actually represent the things we care about. And we can take this nougaty goodness, and we can put it into a model, a much more simplified form with much, much fewer words. What we have here on the left is part of the model actually that we use in the demo, that describes the networks that we have in the demo. And it's not just the one network, as you see on the right, but it's actually the entire VPC. And VPC in this is a very generic context of virtual private cloud, not capital V virtual private cloud, but the idea of a virtual private cloud exists in most virtualized platforms. And so we define the entire virtualized cloud. We define the CIDR for this entire virtualized cloud, and then we define the networks in a model. And instead of all these words, what the model does is it attributes the use of that particular value by its relative position in the data model. But it is much more simple and much more compact and much more easily to apply to different infrastructures. With this model-driven approach, we can actually automate all of the things, and that's what you'll see later in this session. We can automate deploying a particular spoke architecture into AWS, and we can take that same model and we can put it into Azure. And then from that model, we can pull the things to define our local network on our corporate, in our corporate data center. And then we can define all that we need to hook all of the things together, possibly using the parochial peculiarities of those particular clouds. So you can automate all of the things, not just some of the things. You can automate all of the things with a single model and not have 5 models to automate 5 different things. So clearly, a lot of advantages in using models to abstract automation. And so this is the approach we take with Ansible. Ansible using a model to automate infrastructure. We can give you the ability to take any model, whether it's a model that you come up with or a model that a vendor provides, and then encode that model into any form, CLI, for example, for sending out to a Cisco router, XML, also probably to encode to send out to a Cisco router or a Juniper router, and JSON to send via API to make, for example, cloud calls or to calls to devices that only use API. In doing so, we give you the full benefit of flexibility of choice, right? This abstraction through automation allows you to not have to incur the penalty of partaking of choice. You can add new things, whether they be public cloud things, whether they be on-prem private cloud things, whether they be new hardware, and you can abstract it through models and you can automate that thing. So you can automate that thing. You get in the mode of thinking at the application level, right? And at the infrastructure application level are things like the application level is things like load balancing, is imparting or imposing policy on a particular thing, or routing, or quality of service, or pulling these things together into a, let's say, hub and spoke topology. You can think more about the architecture. You can think more about the applications that help you build that architecture instead of, again, the parochial peculiarities, as you can tell I like that word, those words, of that peculiar infrastructure, right? By doing so, you can decrease time to value, right? When you want to add a new customer and that customer needs a new thing or wants to expand into a new node, you can onboard that customer much more quickly. And you can service change requests much more quickly because, again, you don't have to translate that, or the customer doesn't have to translate that into a particular infrastructure's nomenclature. They can just communicate the business requirements, the business objectives of what they want from the cloud. And then you can use this abstracted model, this abstracted view of this infrastructure to deliver those services. You can also reduce the time to remediation and maintenance. It can automation in general, but again, the model-driven form of automation that allows you to abstract all the things, allows you to do maintenance much more quickly, allows you to debug much more quickly. So faster troubleshooting, faster time to remediation. So these things, whereas if you consume cloud resources or consume new resources or automation in general as it is today, you have the potential to actually complicate your IT infrastructure. With properly done model-driven automation, you have the, you increase the likelihood of being able to successfully deliver value from automating your infrastructure.
So interesting problem. So how does all this model stuff relate to hybrid cloud? So interesting problem. Customer came to us and said, we have a situation on our hands. So just real quick, my scientific method of polling, how many folks here run private cloud infrastructure? How many run public cloud infrastructure? How many people need them to talk? So right, it's a problem that really is facing everybody. And what this particular customer came to us with is they had a particular problem whereby they had copious amounts of data infrastructure built on their private cloud, but due to a variety of reasons, some of them security, some of them regulatory, et cetera, that data could never leave their private infrastructure. However, they had a development team that wanted to adopt a very agile way of performing or doing software development. And they couldn't rely on waiting for their internal IT organizations to provision resources for them to write their application. So, of course, what they do what we all did. They plunked down the credit card and they went to AWS or GCP or Azure and they built out an infrastructure and they started writing their application. That was great until all of a sudden they needed access to that data. So how do you solve that problem? Well, in most cases, in most organizations today, you solve that problem by, as I'm a developer, I'm going to call IT or I'm going to fill out my ticket and say I need to connect my public instance to my private data set, and then I sit there and I wait for 1 week, 2 weeks, 3 weeks, 4 weeks, 5. By the time it gets around to actually being provisioned, I'm long past that problem. I've moved on to something else, and what should have been potentially an opportunity for the organization to have a developer solve a problem has now just kind of drifted off into nowhere and forgotten about, and things go on. It creates a real dilemma for organizations because they're unable to leverage an agile development model and support innovation because of this problem. And so they came to us and they said, how can you help us solve this problem? So the answer is we needed to find a way to be able to connect these clouds together, and that's what I want to walk you through. We started with this idea that we had to find a data model that ultimately ended up working for being able to connect clouds together. So we started with Ansible, and Ansible really kind of being a language that allowed us to talk across all of the various disciplines, whether it was cloud, whether it was network, whether it was systems, so that we could begin the process of putting together kind of these virtual teams of these various components and start to drive some of this model development. I totally forgot I had this in my hand. So by leveraging the Ansible engine, we can now build out a model that will support any cloud across any network infrastructure and be able to automate that so that as customers start, or as you start to connect your applications across the infrastructure, I apologize, I need to set that down because it keeps going off. As you start to connect your applications together across your infrastructure, we could put this in a singular model approach and then repeat this over and over. So whether I needed to connect to AWS or I need to connect to GCP or I need to connect to Azure, we could actually have pre-built playbooks that allowed for these connections to happen. And that was really the impetus for putting together this model-driven approach. So we spent a fair amount of time really putting together what ultimately is this model. And I'm skipping those two slides because they're completely useless in the context of this discussion. I did want to get to this one, though, because this is actually what we're going to show. So in this demo, I want to show you what this model is. I want to show you how we approach this problem, because in approaching this problem, what we've been able to do is we've been able to circumvent now having to deal with internal IT and having to wait the time period for them to be able to build connectivity for us. And we can now do this almost on an on-demand service. In fact, so much so, and I'll show you in a moment here in Tower, that we can actually build almost a self-service style portal that allows developers now, at the click of a button, to actually be able to deploy a VPN connection that not only takes care of the cloud side of things, but also works through the intricacies of the corporate network infrastructure so that we get that secure link and we can connect applications to data. In a kind of as we put this together, it really ended up being a lot simpler, I think, than we really thought it was going to be at the beginning. It really just starts with we provision the cloud node. in the first step. The second step is we build out the router infrastructure. And then the third step, we build out the private infrastructure. And the reason we're able to do this is because of the investments we made in Ansible to be able to not only control cloud and development and systems pipelines, but also be able to do the network, security, and load balancing side. So we can generate a single language that allows us to ultimately perform this activity. All right, I'm going to jump off slides. Now, there was I'm going to come back to that in just a moment. So there was a great debate. I'm going to start this demo, and then I'm going to talk about this for a minute. There was a great debate. You know, do you try and actually build a hybrid cloud when you're sitting in a conference room that, using Wi-Fi? And the answer was no. We're going to just show a video, and there's a couple reasons why. We actually just recorded this 2 days ago. 2 days ago we recorded this. So essentially what this is going to do is this is showing you how we can just through the simple click of a button, leverage our data model for going out and being able to start to build a cloud. So here's step one, where we go out and we start to create the cloud infrastructure. So leveraging the survey capabilities of Ansible, we're able to prompt the developer for various pieces of information that we need. And from that information, we take it through a first compilation step, if you will. So what we do is we take all of this information, we munge it with how the model is built. I'm going to show you here the model in just a moment. We munge all of this together, and then we essentially create from here a set of configuration templates for traditional devices, a set of resource manager and or CloudFormation and or GCP template implementation. And then in a second phase, we will then go apply that to those various components and be able to validate this as we bring it up. Go back to, this is just another look at essentially the pipeline I just talked to you about. And it kind of shows how we're taking this approach. In doing this, though, each step along the way, we're able to actually validate what's going on each step. So that as we move across this pipeline, whether we're deploying to the cloud infrastructure or we're deploying to the on-prem, we're actually validating, did that component get deployed right? And if not, we can stop the pipeline at any point and say that you know, we're unable to onboard it, and therefore we don't have developers that are wasting time. Oh, I can't talk to my data. I didn't know, you know, this isn't working, that isn't working. And we're actually able to leverage that each step along the way. So let's get back to the demo. And okay, so as the demos continue to move forward, what it's doing is it's actually building out now the AWS instances. And in a moment, we'll see there is the cloud instance that is in the process of being created. This demo actually takes, this actual playbook actually takes about 20, sorry. About 12 minutes to get the cloud up, about 20 minutes overall, and a lot of that's due to waiting for cloud routers to restart themselves as we apply the configuration to them, which is another reason why I didn't want to run through the full demo for our particular session here. So anyway, it's running through the process right now of being able to build out our cloud infrastructure, and I said I would show you the data model, which I do want to do while that's running in the background. So we have this entire model-based approach to being able to interconnect these clouds. We actually have it all available on GitHub. I've got the URLs here in the slides. I'll show you those at the end. But it's under the name of AN Cloud Builder. And essentially what we've done in this particular implementation is we've created a whole bunch of models to get folks started using this particular implementation, depending on what you're trying to do. So depending on what type of topology that need to be supported, depending on what types of configurations need to happen. And in this case, we are doing Spoke 1. Thank you. So let's take a look at that. Ooh, that's hard to read. There we go. So this is actually the model that is built that actually is powering what the demo is running in right now. So what this model is based on, and Stephen was showing you some elements of this, but you'll notice in this model there is nothing in this model that says AWS, there's nothing in this model that says GCP, there's nothing in this model that says Cisco. So we can actually reuse this depending on what type of infrastructure we need to build and how we need to build it. By focusing on just the networking bits, and that was the real key to this thing. We didn't want to take this so far that we're trying to build out the workload and trying to build out everything on top of it. This is just simply designed to say, I need to connect my two endpoints together so that I can get my applications talking to one another. I'll just scroll down here a little bit, just to give you a sense of what this model looks like. So the model's available on GitHub. It's available to anyone to grab, fork, pull, use in production. Essentially, use it in any way that you see fit. Let me go back to the demo. I think the demo is still running. Okay. So this is what I was just saying. How do I get my hands on the code? Let me put that back in full-on presentation mode here. So how do I go ahead and get my hands on the code? This is the URL to the Cloud Builder model and subsequent roles and playbooks. So it's available for anyone to pull down and start using. We have it at the Network Automation org on GitHub. So fork the repo, implement your use case, contribute back if you want. The pre-built models in there should cover most all of the use cases, at least the ones that we could think of, but there's always room for improving those and adding to those and whatnot. And then go back to our demo. So I'm waiting for the demo to actually finish. Let me see.
It's waiting for the routers to boot up.
Yeah, this is the part where it was waiting for the routers, exactly.
Kind of like watching paint dry.
It is. I'm going to move beyond it just a little bit here so we can move this along. There we go. So once the router finishes booting, now we're in an environment where we've got cloud instances built. We've got the routers are being provisioned right now. So we got the router instances up and running. Now we're going to provision the routers in the cloud infrastructure. And we're looking at the workflow component here of Tower, if you've never seen it. Essentially, this allows us to stitch together these various constructs. And actually, this is a good point, and one that I was remiss in not mentioning earlier. When we built the cloud model, and the way that the cloud model is designed to work is we can stitch together different roles, which means that we can have the different parts of the organization. I talked about having virtual teams. We can have different parts of the organization actually control their specific domains, so nobody has to have full authoritative control over the end-to-end pipeline. Now, it doesn't mean that they can't, but for organizations that, you have network teams who they want their network bit and they want control there, and you've got the cloud folks and they want their control, and that's perfectly fine. This supports that style of deployment and that style of a model. And that's actually how it was built to do. And it's the workflow capabilities within Tower that actually allow us to ultimately achieve that functionality. And while that's continuing to build out, one more thing I wanted to show you here was what this really looks like on the backside. This is actually the system that is performing the demo. And I talked about this self-service approach, so I want to go back to that for just a moment. No, I don't want to save that. Go away. Let me make that a little bit bigger. So this is essentially the representation of what that whole hybrid cloud model is all about. So we have a whole set of jobs now that we can essentially present to the development team and allow them to, through Tower, decide how they want to go out and build their connectivity. So by clicking on each one of these at various points, and we could actually stitch these all together into one big job. We've got it split up for demo purposes right now. But essentially, we can have now a self-service approach where our developers can simply go to a portal. They can click on a job to run, and it will go out and build their VPN infrastructure, connect their data and their workloads together, and never have to involve IT, never have to involve the network team, and immediately get them up and running and productive in a faster, consistent, and repeatable manner. So as our demo here is wrapping up, there it is. So now that we've got we actually have our provisioning done in the cloud, we have our network provisioning done, we're now going on to the final phase, which is actually starting to provision and actually connect the services. So I'm going to pause here for just a second. Any particular questions about what you're seeing so far? Yep. You don't have to use Tower at all. We just chose to use Tower as an opportunity to showcase it. But really, this is all built using just standard Ansible playbooks and Ansible roles and can be run just fine through core. Now, the one function you don't get without Tower is the workflow capability, right? That's brought in by Tower, and that's what allows us to do the domain segmentation. But you could essentially emulate that same thing with multiple playbook runs from the CLI. Okay. And to wrap up, we've got, I'm going to move this just a little bit faster. There we go. So now that we've got our cloud infrastructure built, in the final part of this demo, we can actually destroy the same clouds in the same way and in the same manner. So now, by leveraging the fact that we can build the cloud, we can provision the cloud interconnect, and now we can destroy the cloud interconnect, the model actually supports all three of these. We can put them together, we can run them independently, but it allows us now to really take the burden off of the internal IT folks, and specifically the internal networking teams, and allows the developers to get up and be productive in a much faster and in a quicker manner that allows them to connect their cloud infrastructure. More importantly, what I really was another interesting side note of this particular deployment is it allows us now to have a consistent policy for how we interface with clouds. So whether we're building to a connection to AWS or GCP or Azure or Alibaba or name your favorite cloud infrastructure, we now have a consistent way that follows the internal standards and requirements of the organization for how those connectivity is built, how it's provisioned, and what the life cycle of that ultimately ends up becoming.